Yeah, I'm going to report the results of some experiments that have been conducted as part of a GRDC funded project looking at early sowing in the southern region. And I'd like to acknowledge a great raft of co-authors. All these trial sites are from South Australia, so they've been planted and managed by largely by SARDI, but also AgriLink agricultural consultants managed a site at Leigh, and Hart Fieldsite group who sort of put a trial in off their own bat based on their core funding at Hart. And also I'd like to thank the trial hosts, particularly Barry Mudge, who sort of discussed a lot of these things with over a long period of time. So I'm going to start with some take-home messages because we're in the session after lunch and things can get very sleepy, so you can nod off after this. Based on our 1 year of data, and we'll be repeating the trials all again this year, it looks like Trojan is a real complement to maize in a cropping program and really lets you open up the sowing window by about 10 days further than you can achieve with maize, and as I'll show, probably has some pretty solid positive implications for whole farm wheat yield. In South Australia, there's really no spring wheat variety that you can plant before 20th of April in any frost-prone environment. So the non-coastal environments, you really need to be using a winter wheat. But there's no adapted winter wheat, so that has some implications. In the sort of current cultivars available, and wedgetail's the most realistic one, sown in mid-April in our trials, are very unlikely to out-yield maize sown in its optimal window. But in a lot of our trials, it did out-yield maize sown too late. So I guess in terms of a whole wheat cropping program across a farm, you may be better off sowing wedgetail in the middle of April. So most of your maize goes in on time around that early mid-May, and you cut out these late sown paddocks. So that's probably where the fit and the value of something like wedgetail is for the moment. But I'll sort of argue that South Australian growers would really benefit if there was an adapted winter wheat for this part of the world. Wedgetail just has extremely poor adaptation to alkaline soils, is the reason why it doesn't do better. And the good news is that there's some in the pipeline. In southeast South Australia, it's kind of a different environment to most of the traditional grain growing areas, and I will have to kowtow to the pathologists and say that disease pressure, particularly from barley yellow dwarf virus and Septoria tritici, is really going to restrict early sowing options in that environment unless you're grazing, using a dual purpose winter wheat like Manning, which is barley yellow dwarf virus resistant, and grazing does go quite a way to controlling Septoria tritici if you're sowing in March, April. So into the core of the trials. This project had 5 sites across SA: Minnipa, Cummins, Port Germain, Tarlee and Conmurra. And as I say, the Hart Fieldsite group put in a trial of their own. The experiments were all largely identical with a few local tweaks. They all had 3 times of sowing, the first being in mid-April, and if there wasn't any seedbed moisture, the first time of sowing was watered up with drip irrigation in order to guarantee establishment at that time. The next time of sowing was generally early to mid-May, and the last was in late May. We had 6 best bet commercial cultivars representing the range in maturities that we have available in Australian milling wheats. And we also had a research tool in the form of 4 near-isogenic lines that varied for their major maturity genes, which is helping us look at what sort of wheat maturity type is best suited for early sowing in South Australia. So this is just a picture of the Conmurra site and the SARDI crew there watering up their first time of sowing with drip irrigation in the seeding furrow. So a very small amount of water just applied to the furrow guarantees establishment but doesn't really affect yield beyond that. And Cummins was also watered up, but Minnipa and Port Germain, they were established on actual rainfall. So just looking at the cultivars that we had in the trials in these, I guess, traditional grain growing areas, we had 2 winter wheats, both bred in southern New South Wales. So winter wheats have a vernalisation requirement, which means they have to experience a certain amount of cold temperature before they'll go on to flower, before they start to go reproductive and elongate and flower. And that's what's largely causing their delay in photoperiod. Eaglehawk, also from southern New South Wales, or adapted to southern New South Wales, is very slow maturing, but it's a spring wheat in that it doesn't have this strong vernalisation, but it has a very strong photoperiod, so it responds to day length. It only flowers in long days. And after that, we get into cultivars that are adapted to South Australia, or better adapted to South Australia. So S-stock being one of the longer cultivars adapted to this part of the world and best yielding. You'd call it a mid-maturing spring. It has quite a strong photoperiod hold. Trojan has slightly weaker photoperiod than S-stock, but still delays it more than Mace, which is photoperiod insensitive. So its development is really largely just driven by temperature accumulation. So the warmer it is, the faster Mace will flower, regardless of day length. At Conmurra, we had a different cultivar set because we wanted varieties that were adapted to that part of the world, but similar sort of groupings in that we had a couple of winter wheats, a slow maturing spring, and then into, I guess, the adapted lines. Now, I just wanted to briefly talk about the genetic control behind these wheats, because it's important once we start talking about the near isogenic lines, and it's good to think about as well when you're choosing varieties, what sort of developmental holds your varieties might have that make them suitable for early sowing. So these are the 5 major maturity genes for which there are markers that exist in wheat, and these different letters represent the different alleles. So there's 3 main vernalisation genes, 2 photoperiod genes, a B here, and it's highlighted in green, or C or D, means that it's photoperiod sensitive. So it needs long days before it will flower, whereas A is insensitive. Over here on the vernalisation 3 columns, a V means it's the winter habit at that locus, and A is the spring habit, and B is it's a spring allele, but it's intermediate between the A and the V. The main thing to get out of this table is that the more green you have up here in these slower maturing varieties, the more holds or delays you have to maturity. And most importantly, have a look at these winter wheats here. To have a genuine winter wheat with a full vernalisation requirement, you need to have 3 Vs at A1, B1 and D1 before you get that full winter habit. And then as you move down to the faster maturing cultivars, you have less and less holds. So Mace is insensitive to photoperiod, but interestingly it has 2 vernalisation genes, but you need to have the 3 before you get that winter habit, so it's still quite fast. The near isogenic lines are using those genes crossed into a common background in order to create a set of cultivars that are 97% genetically identical, but they vary only for those major maturity genes. So they're a useful tool if you want to develop, to look at the effect of development in a given environment, because you've taken away all the other genetic baggage that you might get from comparing, say, Mace and Wedgetail, because Mace is obviously hugely well adapted to South Australia and Wedgetail is not, so it's not really a valid comparison to make if you just want to look exclusively at the maturity. But these lines developed by Ben Travaskis with GRDC funding let you do that. And this is just to give you an indication. These are 6 of the lines going from something that's quite strong winter to something that's very spring. These plants are all the same age, and that shows you the range in development you get. And we had 4 of these lines. There's, I think there's about 60 of them. We just picked 4. We picked a mid-maturing winter, so it's a winter wheat with a little bit of photoperiod sensitivity, so that behaves like Wedgetail or Rosella. We had a fast winter, which is a photoperiod insensitive winter wheat, so there's nothing like that exists in Australian commercial cultivars at the moment. It's much faster than Wedgetail, but it's still a proper winter wheat. But once it initiates, once it's experienced its vernalisation, it's very quick to mature. So that's the sort of idiotype that we might expect to perform well in South Australia. We have a very slow maturing spring wheat like Eaglehawk with 2 sensitive photoperiod genes, and a fast spring wheat which has different genes, but it behaves very similarly to maize in that its development is largely driven just by temperature. So I'll just go through the trial results one by one and then have a look at the summary. This is the Minipa trial in September. And here are the yield results. It's important to point out that this trial site was on top of a hill, so there wasn't a lot of frost damage in the trial, even though a lot of the best performing cultivars, and probably particularly Trojan, would have flowered too early in that environment, or what you'd consider to be too early in an environment that can experience some frost. So the highest yield came from Trojan at the 11th of April sow date, but yeah, I'd say that was a highly risky proposition in most frosty environments. It might be okay in coastal environments. And that did have a significant advantage over maize in its, well, probably getting to the end of what you'd call its optimal window. Wedgetail sown on the 11th of April yielded as well as maize sown in its optimal window in this case. So I guess there is an argument there that there could be value in growers having something like wedgetail to be able to start the window a bit earlier. And it yielded the same as maize sown too late as well.
So why did Trojan out-yield Eaglehawk in early summer?
Because Eaglehawk flowers too late. Wedgetail.
Yeah.
In a dry, frost-free spring, the first to flower wins, to a point. So maize was the first to flower, Trojan sort of hit the sweet spot, and wedgetail is just too late. And wedgetail is just a bit too late in most of South Australia, because in southern New South Wales, where we come from, like you're aiming to flower in the first week of October. Down here, it's more like the middle of September or early September, so it's just a bit late. And this is really what's driving the yield response between Trojan and maize when you sow them early. It's basically Trojan's photoperiod sensitivity gives it a strong delay when you sow it early, so there's a month difference in flowering date between Trojan and maize when you sow them early, but by the time you're into May, there's only about 4 days difference in when they flower. So that's when they're sown from the end of April onwards, their yields are very much equivalent because they're flowering effectively at the same time, but once you get into April, you'll see Trojan and maize drift apart because maize bolts and Trojan's got that photoperiod hold. This is the trial at Cummins and a few grinning landmark agronomists in it. This trial site had waterlogging, so there's a bit more variability. The LSD is a bit higher. And the highest yields, there's also frost at this site, and maize at the first time of sowing definitely caught that frost. And the highest yields came from Trojan and maize at that 6th of May, I guess what you'd call that traditional optimal window sowing time. As I say, maize caught the frost sown early. Wedgetail sown early could not yield as well as maize or Trojan sown in their optimal window, but it yielded the same as maize or Trojan sown too late. So again, that's where you might pick up that value of the very early sowing. This is Barry Mudge in the trial site at Port Germain, sorry. So quite a frost-free site by the sea, though Barry did report his first ever frost, I think, last year. And in this environment where, frost risk is extremely low and people do comfortably seed in the middle of April, maybe sowing Trojan and maize that early is okay. And you can see, obviously Trojan sown then yielded extremely well compared to maize in its traditional window. Winter wheats don't perform in this environment because it's too warm. They don't vernalise, and so they flower too late. They stay vegetative for a very, very long time. So, a word of warning for anyone interested in dabbling in winter wheats is that they don't work in coastal environments. And no comparison to maize sown on the 20th of May. This is me standing in front of the Hart site pretending that I actually had something to do with it, which is a complete lie. But I do have the results, and once again we're sort of seeing that pattern repeat, that Trojan sown on the 14th of April, and again I'd say in this environment that's probably too early for Trojan, but in that season yielded extremely well. Maize and RAC 1843, which is sort of axe type maturity, caught the August frosts and were quite heavily damaged. So maize Trojan doing better than maize in its optimal window. Another environment where wedgetail sown early could yield as well as maize in its optimal window, and better than maize and even the faster maturing variety sown late. So you're better off taking a variety like a wedgetail and getting it in early than relying on a very fast variety like 1843 or axe at the end of the season, if you get the opportunity. To Leigh is Mick and Jeff in an enormous crop of eaglehawk. In this site we had 4 different sowing dates, and we sort of slipped in an end of April one, which is where Trojan and maize were neck and neck and topped the trial from that sowing time. Back in the middle of April, maize again caught those August frosts, so its yield was well down. We didn't have wedgetail at this site, but we did have Noack, which is something of a surrogate, and again you can see this this pattern that sown early, yields similarly to worse than maize and Trojan sown in their optimal window, but is better than maize sown late in the season. Conmurra site, here's Matt standing in the plots at Conmurra. It's kind of a different environment, and I think the disease pressure there really drives things, and I can't really see a lot of scope for sowing much earlier than the middle of May. The highest yields came from Trojan, sown 6th of May and 30th of May. If you were going to sow something early, Manning is the thing to use because it has barley yellow dwarf virus resistance, and BYDV played a very strong role in these results, even though we took quite a lot of, well, SARDI took a lot of preventative steps with insecticides. And revenue does quite well if you can get it out of the BYDV risk. Septoria pressure was very low in this season, thanks to Hugh Walwork putting a Septoria nursery right next to this trial. You couldn't find a pustule for the whole year. And that's the sort of BYDV pressure the first time of sowing was under, and that's the relationship between BYDV, which I scored on the 2nd of October, just a visual plot score, and grain yield at the end of the year. So it had a really, really strong effect. Okay, just to try and summarise, I guess the main cropping belt sites. This is the mean of those 5 sites only in 2014 of Trojan and maize, and I think what it really demonstrates is that Trojan complements maize in a sowing program, and that maize in its optimal window is very strong once you push it too early, and I think we really saw that in those farm data from Matt McCallum. It will start to drop off because it's flowering too early, it's not accumulating enough biomass, and it's running the gauntlet of frost. But that's probably where Trojan can step in at that end of April sow window to try and offset some of that risk and improve that yield. And they're very complementary varieties in terms of their risk profiles. So maize is obviously AH, Trojan's only APW. Maize has stripe rust and leaf rust as potential weaknesses. Trojan's quite strong on those, but is weaker on yellow leaf spot where maize is strong. So you kind of balance a lot of risks with those 2 varieties. And yeah, I think there could be a lot of value picked up in if people just know the optimum of their varieties and learn to switch when it's moved out of the window of a given cultivar. So I think, yeah, if people just have a better appreciation of their optimums for a given cultivar and their environment, And remember that spring cultivars really only have a 10 to 14 day window where you're probably better off switching to something else. So yeah, if you know the optimum, just keep a cultivar within 5 to 7 days of that. And in terms of minimising stem frost risk, that's a really big thing. And as I say, if you're going earlier than the 20th of April in those frostier environments, you really need a winter wheat, and wedgetail is probably the most likely customer at the moment in terms of getting seed. So just an example of sowing dates that I presented these in the session this morning. That's kind of the range that you get out of good adapted spring wheats in South Australia. The window opens on the 20th of April with Estoc and Yitpi type maturity, move through Trojan and Phantom, and Coral and Espada are probably in here somewhere as well, into Mace and Cobra in the middle of May. Down at this fast end, these things mature faster than Mace, but they probably don't necessarily yield more than Mace sown at that time, so it's questionable whether there's any value switching to one of these varieties, or if you're just best sticking with Mace all the way through from there. Something that I think is very interesting, these are the results from the near isogenic lines, and they're the mean from 5 sites in 2014, but also Tarlee in 2013, and I'll just point out that this data point here only comes from Tarlee, so that's only one trial behind this one, but these are 6 trials behind these points here. And I just want you to look at the difference between the fast spring, which is our Mace type maturity, which is these dark circles here, versus the fast winter, which is this idiotype that doesn't yet exist, which is these hollow circles here. And I think that offers a lot of hope that if we can get a cultivar that behaves like this and is adapted to South Australia, that our sowing window will really open right up well past the 20th of April, and it'll give growers something that can be planted from late March probably through to early May and be competitive with those spring wheats. And the good news is that several breeding programs have some in the pipeline which will hopefully have adaptation to South Australia. All the winter wheats that were bred in Temora don't go well on alkaline soils. And just to demonstrate, I think, what could be the potential, these are results from Junee, from CSIRO-funded project to develop novel germplasm for early sowing. These are yield results for winter wheats that have been selected from spring wheat crosses. So these are the spring wheat parents that have given a winter progeny. They're only F3 segregating populations, so they haven't been selected for yield, but under pretty extreme stem frost pressure, and that's really driving a lot of the yield response, you can see that they're all performing a lot better than the ageing winter wheats we currently have. So Whistler was released in 98 or 99, Osprey 1983, Whistler was the end of the 90s, and Wedgetail was the last in 2002. So I think using these modern high-yielding parents like Mace and Espada and Gregory will instantly give us winter wheats that can be pretty competitive in this part of the world, hopefully. And that's just to show you how strong winter wheats are in terms of surviving stem frost. That's slow maturing spring wheat that's got a lot of vegetative damage, whereas the winter wheat, particularly with that erect Espada-like habit, is fine. And I'll leave it there for questions.